with conditional probability. We're now back to building probability again. So what we have so far are our sample space, our event, the complement, the union, the intersection, and the empty set. We have our axioms of probability, which tell us how to work with probabilities based off these set options, right? We have these events and these and operators. So this gives us a way to determine probabilities from these events. We have the complement rule, we have the union rule, we have the intersection rule. And then the next thing we want to do is we want to look at something a little bit closer. Suppose we have two events, E and F, and I tell you that an outcome in E has occurred. Okay? How does this change the probability of F? Okay? So, we no longer need to consider any outcome that is outside of E. Okay? So, all the outcomes outside of E, also called E complement, are not under consideration anymore. So what we would do is we would say, well, what do they have left in common? Okay, so the only thing that we need to consider about F are those that it shares with E, right? Because we already know that the event is in E. So, or the outcome we're interested in is in E. So we've defined our conditional probability here to be the probability of F given, this bar here means given, E is equal to the intersection, the probability of the intersection, over the probability of the one that I'm told already has an outcome occur in it. And this has the requirement that that has to have a probability greater than 0. Not greater than or equal, greater than 0. We can't have a 0 in the denominator. So let's look at a really quick example here. So the following cities are vying to host the next World Cup of Data Science Championship. So there's some all over the place, right? I've got Tupelo, Mississippi in the USA, La Serena, Chile. I've got Saskatchewan, Canada. I've got Swift Current in Saskatchewan, Canada. Zadar, Croatia. Varna, Bulgaria. Mongar, Bhutan. Makassar, Indonesia, and if I'm pronouncing these wrong, just you'll have to forgive me. I'm an American, and we're horrible at pronunciation. So, we are told that all locations have equal probabilities of being selected. So I'm interested in Kambar, Pakistan. What is the probability that if they're all equally likely to being selected, that it comes from Kambar? Well, there are 21 locations here. And Kambar is one of them. So the probability is 1 over 21 because I'm not given any other information. But suppose somebody tells me that the winner will be in Asia. What does that do? Well, now I can throw away anything that's not in Asia. Okay, so all the European ones go, all the ones from Africa go, all the ones from the North America and South America are gone. And if I look at this, well, the probability that it came from Asia is equal to 6 over 21, or 2/7, because there's 6 of them out of the 21 that are in Asia. Now, what I would like to know is what is the probability that it's Kambar given Asia? Okay, well, now I have to pay a little bit of attention here, but if I pay attention, I notice that there are only 6 from Asia, and Kambar is one of them, so it's 1/6. So we don't even need to use a formula to get this. But notice how the probability changed once we have additional information. We went from 1/21 to 1/6. So the probability went up considerably. All right, so this is our first little example of looking at this. Let's look at another one. So we already have that the probability of Kambar given Asia is 1/6. Well, is the probability of Asia given Kambar equal to the probability of Kambar given Asia? Well, we need to think about this. Well, the probability that it's in Asia, given that I told you it's Kambar, is equal to 1. Why? Because Kambar is in Asia, right? There's no other option here. There's no other option at all. Kambar is in Asia. So the probability it's in Asia, given you told me it's in Kambar, is equal to 1. So these don't equal each other. And this is going to spur our need for a theorem to help us flip these over. But first, we have some other things to talk about before we get there. But the big thing to take away is we have this idea of conditional probability that when I get more information, it changes my probability. And this change in the probability is important. And also that these two is not symmetric in the sense that you can swap these out in any order. All right, so we can add these now to our list in our summary. Here's everything we've talked about so far, and now I've added these two just so you have a summary as we go along here. And if you're making a formula sheet of ideas, here it is. And you'll see us keep adding to this until we basically run out of space. All right, so we'll move on to the next video, and we'll see you there.